to begin with, we say data visualization needs some creativity. Okay. Imagine you're asked a task to map the global consumption of plastic bottle since 2009. How would you do that? Let's think about it maybe 1 minute, and whatever ideas, feel free to let us know. Or you can type in the chat box.
Are you asking like the type of graphs or infographics?
Yeah, it could be if you have any idea. We also have some answer. A line graph, yes, it could work. So maybe what you would expect is from 2009 to today, it goes up annually. Okay, that's good. Or the other idea is people use a bar plot. So this is the number of total plastic bottle looks like. Okay, I would say this regular plot. Any other ideas? Okay, how about this? Can anyone help describe this figure?
I think that's like a mountain of plastic.
And compared to the New York City, right? So the difference between this figure and the more statistical figure is it gives you a very intuitive sense of how much of the plastic bottle. Otherwise, it would be just a number. Let's say 2 million or 3 million, or maybe it's 2 or 3 billion plastic bottle. So that's fine. And that's still good for scientific purpose. But if you want to educate people, compared to something people are similar, because we know New York City, that's a huge. But then look at the mountain here, it's made up of the plastic bottle. So if you look at the size, the area of volume, it's almost half size of the New York City. So this is one of the creative way where you can summarize information and communicate to the general public. So one example here. Now, the other example, let's say we have fires. Particularly this year, we have lots of fires in the West. So some of the fires they're caused by natural or human natural disaster, and some of them are caused by human activity. So how would you summarize the number of fires in the US? A plot here, this is the simplest version, a bar plot. Okay, characterize the number of fires, the burned area from 1980 to 2018. But it seems a little too boring. So okay, now I saw answer people say heat map. What is the idea behind heat map? Could you explain a little bit? So I think that's coming from Alexis.
Yeah, a heat map is like you have a map of the area, a geographical map, and then on the areas where the data is there, if there's more data, say more fires, it's darker, and if there's fires, it's like a lighter color.
Yeah, that's great. Actually, the example is quite close. So maybe let's first look at something like what you have described. A heat map over the geographic space. So here, from purple to yellow, it's an increasing percentage of the burn caused by human activity. So you would see like most of the fire burned in the West, now except the Silicon Valley, the Central Valley in California. Most of them are actually natural, caused by natural disaster. And then in the Southeast US, Central Valley, much of them are caused by human activity. Okay, and the brightness here illustrated the intensity, and you can see the different size of the circle. Okay, and what does the circle mean? Actually, it means the number of events. Okay, so from all the way back from 1950 to 2020, so each of the dots, a circle, is the 5 events happening for each of the months. So some of the months is like particular, this one is eye-catching because it's a big circle, meaning, okay, there's many natural causes fire compared to human fire. And you can also see the difference in timing as a natural induced fire events normally happen in the summer. It's easy to understand because maybe we have lightning, or maybe the temperature is too hot. But then for the human caused fire, some of the big fires, they were even happening in the winter time. That's mostly, I would say that's in California because the dry season and then the moderate temperature favors of the fire spread. Okay, so this is an example like how you can turn like a little bit boring statistical table into a more like storytelling figure like this one. Okay. The other example, figures, data visualization, it doesn't have to be figure, it could be table, but then how you organize the information, it does help a lot to communicate your key message. So this is a figure I take from a website. It's describing like after COVID, now different country has a different responding strategies. Some are cheap and some are expensive. Not trying to look at a particular country, but in general, like if you act quickly in the early stage, many of the cheap strategy you can apply, and the more you apply, the less you have to pay the cost later. Okay, and then from Asian to European country, and we know here in the US, we do have some slightly different strategy, and then this is what you see. Eventually we paying a little bit too much. Now I think this figure can be improved by not saying just yes and no, because it indicates black and white. I would say many of the strategy, there's more like a continuous variable. It's just maybe some country did 10%, some country did 100% or 90%. So if you plot the quantitative indicator and you summarize later, you probably will find if you don't do 80%, like if you don't score 8 credits, then regardless of how much effort you do in other, collectively, you probably don't expect a successful mitigation strategy. So that can highlight the importance. You take care of every aspect of the whole pandemic, not only one particular thing. Education of wear face mask or having the vaccine or having the social distancing. Not saying, okay, we did 100% on social distancing, then we are okay. No, you also need to take care of others. So having a quantitative score maybe improve this figure a little bit better. We have many choices to make a figure, okay? So some of you may have seen the scatter plot, geographic plot. This is more like an evolution relationship plot. This is a bar plot, and this is a type of plot typically used for population or demographic statistics. And of course, like a few other line plots, what is this bar plot, okay, and the maps. Now, different plot are different, the type of plot, they are different in highlighting the key message. So next, what we want to do is let's try some practice and see if you can find the science behind an effective visualization. What is the third largest segment in the chat? Okay. Oh, the answer, okay, we have more people believe the edge, all right, but also quite a number of students have choice the B and D. Well, I'll tell you, H is the correct answer. But then see, we had less than 50% of the people believe H was the third largest segment. Now, this question tells you, okay, when you use a pie chart, it's extremely hard to tell the difference between a similar size pie chart. So a pie chart is good if you want to visualize what is the percentage of H compared to the total, all right? So for like this one, it's like roughly it's 1/6 of the entire circle, but it's really hard to tell H, B, D, which one is relatively larger or smaller. So if you want to highlight the difference between groups, pie chart wouldn't be the recommended approach, okay? The second one, the height of A is how many times of B? 10 times. We only have 4 students made the correct choice. Oh, okay, so the lesson here is bar plot. It tells you the relative difference. Now, if you have you make a annotation of a text, a number here, it would probably easier for people to quickly make the comparison. So that's why we do see some of the bar plot, they have a text indicating the number of the actual value. But if you want to compare the relative difference, especially how many times exactly, it is hard. This is still a not ideal approach for visualization. The next is cubic. How many times A to B? Okay, the answer is 5. About we have about like 1/3 of the students have correct answer. This is because when you make a choice of the height of the volume, you have to think over like each one over 3 the power. Okay, so even a small difference in the each of the side or the area, it makes a difference in the volume. So use the volume to compare the relative difference, especially like how many times between one group to another. This is a kind of a challenging problem. So still not ideal. The last one, I'm surprised like the shading and luminance or color saturation is a high, is a top choice. Okay, now, how about the position on a scale? Actually, this is scientifically treated as the #1 effective way of visualization because it has a scale and it has a position. So you can easily compare, let's say, move a position here, okay? And then tells you the difference. A chart shows what is the most efficient or effective way of data visualization and what is the least. Now, actually, color saturation was at a very low bottom of this chart. Although there are some personal preference, again, I say visualization, it's between science and art. Some people does have the ability to quickly tell difference, a subtle difference in shading or in color saturation compared to calculating the area difference or volume difference. So I would say the lower bottom part, it depends. But for the upper position, okay, it does make more sense. Like if you have a scale or if you have a lens, it is more easier to compare because you can shift the line here and put it here, and then easily it can tell you what is the difference. Okay, so that's the science behind effective data visualization. Okay, so come back to some of the comparison, like which one is good at what. For example, people are particularly, they tell the subtle difference of one type compared to the total. For example, here. Okay, so this is a cumulative global carbon dioxide emission, not currently the cumulative over the history. Okay, now United States stand out, European country, and then followed by China, Russia, India. Okay, so this kind of using the area to represent the relative share, it's easy for the side-by-side comparison, and also what is the fraction of particular country compared to the total. Okay, and also here, the other elements is you have a different continent colored by different, use a different color, which is the easier, relatively easier way to distinguish between the country. All right, so next, pie charts, as we tried, it's hard to tell the difference between the two groups, but it is particularly a good way to, if you want to highlight, let's say, industry account for 21% or roughly 20%, 1/5 of the total, or a quarter of the total. This is a good way to use. The bar charts, okay, it's easier for make a cross sector comparison, not how many times, but if you want to know which one is taller or shorter or which one is more than the other, bar plot is the correct or is the recommended approach for visualization. The other thing you have to know is sometimes because all data visualization is a summary of your data, so it can be cheat. Okay, for example, the same group of data, the scatter point here, they have the same mean value, the same standard deviation. Okay, so if you summarize them into a bar plot with plus minus and the error bar, you would have the same plot. So this is also example where we see earlier in the lecture slide, your statistical summary, sometimes they can trick you. Okay, so in this case, it's maybe plot raw scatter data is the recommended way to make the comparison. Okay, so that means there's no standard guideline say you have to do X, Y, Z, but depends on the data you have. More often, we don't plot scatter data points, but if they happen to have a similar statistical summary, then what you could consider is actually make the, let me find my cursor. Okay, yeah, you can move the scatter plot and overlay with the bar charts. All right. The other thing is color. Okay, the color matters. This is a figure from NASA. Okay, try to highlight the gravity, and I would say it's visually unappealing because they have too much bright color that kind of blows your mind. So this actually relates to science. Okay, now people see the color in terms of the HSL. What that means is a hue, for example, as a red or blue. And the other key variable is saturation. So saturation meaning the intensity of the color, and the lightness, like is it bright or is it lower? Now, human eyes, they rely heavily on the lightness to interpret the sharp or depth, the information, basically. So if you have more brighter color, you're more easily to catch the eye, human eyes. Now, okay, so the question here is, within this blue to red scale, can you tell which part has the brightest or the highest light, the light intensity? You can type maybe say blue or green or yellow or red. Okay, we had one answer, two answer, good. Third one. Okay, we have a few. Now there's basically two group arguing why is support blue and the other group say yellow. Okay, this is a position within the color scale bar. You have the highest light intensity. So that's why even though in this map, people trying to say, okay, the red part is with the highest value, but because of the yellow, they have the highest intensity. A person without scientific training would often interpret, or he will quickly focus on the yellow part instead of the actual high value of red. Now, I'm thinking, I think because we had a high education training, so we know to look at the color scale and then interpret the map. But if you threw a plot to the general public, more likely their attention will be distracted to the yellow part. Okay. Again, different people have a different buffer zone or tolerance of the color and a different interpretation. But I would say the rule is true for majority of the people, maybe 70%, 80%. Okay. The other thing is we know some people are color blinded, especially red and green. Okay. So there's two alternative color scale, which was voted as the #1 color scale. I don't even this. Okay, this is voted the #1 color scale in 2018. Okay, so rainbow scale, it's easy for most people, but if you have a colorblind like red and green, it's hard to visual the difference. This is actually what they see in their mind. So two alternative color scale come out, and as we progress, there's more color scale coming out. And the good thing about the last one is that it does highlight what they need to, but still in a visually like a pretty comfortable style. Okay. Let's talk about the grammar of graphics. So we see lots of different plots, okay? Then what is essentially a good plot? This is an example, a figure coming from a science paper. Even without the additional text description, we can probably easily tell the key message behind. Okay, so here is the temperature, the difference in temperature, and the number of violent crime. So it clearly shows there's a positive correlation as your temperature increase because people feel hot. So it's more likely that we observe violent crimes. Okay, and then this is a few differences like the rainfall losses and how that could relate to riots. Because if you for like a developing country, water resources is a big issue. Like they compete water for the agriculture, for industry, for or between different village. So if you have a high water loss, and you have a more water scarcity or crisis, you're more likely to see riots among the region. Okay, now separate out what are the actual elements made up of this plot. Is first you have x and y axis. Okay, so this is a key data point: x-axis, y-axis, and then a big plot, you have a subplot. So we have three different panels, A, B, and C. And then you need a subtitle for each of the panel, like highlighted by this blue box. Now you need a legend, tell people what actually you are visualizing. So here it says we have estimates, which is the line, and plus minus the confidence interval, which is roughly the uncertainty. And then you want some color, but probably not too much make a colorful like illustration, but scientific paper or newsletter figure, normally they have some color, but in a visually comfortable amount. Okay, so this is basic element of made up of a effective visualization figure. More, if we break it down, we actually we can summarize them as the C, the coordinates, which is the data point. You may have some statistical transformation. What that means is you have the mean value and the plus minus of the confidence interval. Now you can have a different faucet or different panel and a few others. So I think before I saw this figure, I think of my data visualization just as a plot as a whole. But then this figure helped me to break down a figure into the layer. So when you're actually making your plot, it's just a matter of adding one layer to another layer and then to another layer. So you always start with the data, make a, let's say, scatter plot, X and Y. And then you think about how I can make it visually look better, look more pretty. And can I split into different panel, or should I split into different panel? What is the statistical transformation I could do to make a more summarized visualization? So this layered system is very helpful to you for you to create an effective data visualization. So let's talk about some of the recommended tool. The number one tool, R, is probably some of you have heard of from other classes. R, that's the number one statistical programming language and also extremely good for data visualization. So actually, the grammar of graphics, the layered system, is come up by this guy who is a developer of the ggplot, a visualization package in R. So as you can see in the source code here, look, lots of plus signs. So actually, that means one layer, add another layer, add another layer, add another layer. Okay. Compare the difference between R and MATLAB. Okay. So here, what you can once you set up the structure And if you want to change something, just go to the layer and fix whatever you want to change. This is a function not so well supported by MATLAB. But still, MATLAB can do the basics of the visualization. Now, for example, this is a correlation matrix, measuring the correlation between different variables. For example, here, alumina and calcium, the value here means they have a negative correlation, and also it can be visualized. This is roughly the scatter of the data points. Okay, so negative correlation, weak, not significant, and it's negative. If it's positive, then you have the blue color, and depends on the darkness, it indicates significant, medium significant, or highly significant. So this is made by R. This is the MATLAB version. Okay, so I wouldn't say like if you spend lots of time and tweak the plot, you could get a similar figure like this. But by default, I think MATLAB has a terrible design of the color palette. Okay, so later on, if you're interested, you're motivated, you can learn. You can do the analysis in MATLAB, and then export the CSV file, and then import into R to translate into a better visualization plot. So color matters. So there's a lot of online resources for you to pick up a color. Okay. And this is a website which I will, once I posted the lecture slides, then you can explore by yourself. It gives you different options. Let's say if you want to pick up 5 different color from particular scheme, you can do so with the website. It also, you can pick up to, I think, 11 different color. Okay. What if there's more fun to play with MATLAB, which we will demonstrate later. So basically, is you can pick up whatever photo. This is a twin city, okay? Whatever picture, and then you can extract the color from the picture and to make your plot. So this is a plot default by MATLAB. What I did here is I find a photo, I extract the data points, and then I recolor the line plot. Okay, so this is possible with MATLAB. Let's take a 5-minute break, and the next I will show you the demo for how to make plot in MATLAB. Okay, so I will open my MATLAB. Oh, by the way, any questions so far for the lecture part? We good? Okay. Yep. So let me open my MATLAB. Okay, we look at the MATLAB window. Good. All right, so make plot. Pretty easy. First, let's change the all right, good. So we start with the basic plot. Let's say we have two vector u and electrical the u as a voltage and I1 is the electricity passing through the line. So we want to visualize the relationship. We have to quite a bit. Just make a plot. Okay. Oh. So maybe I should share the entire screen. Okay. Now we are looking at both the MATLAB window and the plot, right? So this is the plot. We make but if we don't have the x-axis, y-axis, so let's keep adding the stuff. This is also, I think you have practiced quite a few times in lab assignments. Okay, now we have the line plots, but it's not easy. Like we can quickly locate which value for each of the data points, right? So one function MATLAB has is a grid, which help you to create a reference bar for each of the data points. Now we can easily read, okay, this data points corresponding to 0.5, 0.5, or 0.6, y-axis is 0.08. Okay, now we can keep changing the font, which is if you want a different font. Okay, make it larger or smaller. Okay, and then adding a title. Okay, so this is also like you keep adding line by line, layer by layer. Now, what if we want to make another plot, which, let's say we have I2, okay? We have I2, and then we hold and make another plot. All right, so because the new line, it has a different range, so your x-axis, it changed. And what if you don't know the exact, or if you know the data range in advance, what you can do is actually you can specify. Okay, you can specify the x and y axis and make the plot. So that way you can better control your the range of x-axis, the range of y-axis. What about the legend? I see some of you actually have a good practice in the lab assignments of adding the legend. Okay, so here we have a legend. First, the blue line is the second group, and the red line is belong to the first group. Okay, now we also mentioned subplot. Okay, now that we do need to close this one and make a subplot. Okay, so a subplot function, if you first call subplot, you want to make two subplot. This is the first column, first row, and then create another subplot first column, second row. Okay, and in between, it's just a regular, you're making a plot. The other thing we could try is what if we want, we have value which has a very different data range, and it's unlikely you can plot them into a same Y scale. So what we do is called double Y-axis plot. Now pay attention to this. Let's see. Oh, try to increase the font size. Well, so Y-axis, double Y-axis here. Okay. Now we have two dependent variable. The first one is the base current. Okay, current versus voltage. The other is a heat emission. Now we can easily notice that the data range for the current is pretty small, but the heat emission is because it's in a different unit, so it's pretty large. If you put them in the same scale, what you would see is a flat line for the current, and then an extremely high increase of the curve for the heat emission. So, but if you put them into a two different scale, okay, so they can be lined up and then help you to compare the general trend in response to the voltage. Okay, so that's a basic of making a plot. The other example a few more example I want to show is we do have more different plot. For example, histogram. Okay, histogram, if you have two group of data, we can easily use a histogram to visualize the distribution of each of the difference. We have a 3D data plot. Oh, I need to redo the plot. Okay, this is a normal distribution of the two independent variable. Now, with MATLAB, you can rotate and try to correlate the value for each of the data points. Okay, that's possible with MATLAB. We can also turn this one into a surface, smooth surface, which basically you make interpolation between each of the value, and then visualize the color in between. Okay, so I will post all the M file into the lecture module and for you to play with later. The last example, what I want to show is how you can make a customized color using your own photo. So first, let's see. Okay, this is the default time series plot. We use a MATLAB color scale. Now let's try our own photo. Okay, so here I use the image read function. It's supposed to give me a, oh yeah, it's just a reading, and then we need to show the image in MATLAB, okay? It's here, and then we want to get more data points. Okay, so we click here, and here, and here, maybe here, here. All right. And okay, let's see the color. What is color? Yeah, we have the color. Now let's try our own data Oh, something doesn't work. Oh, I see. This is what we need to do. We need a 1, 2, 3, 4, 5 data points. Okay. We need 5 data points. 1, 2, 3, 4, 5. Okay, let's see. Color 1, 2, 3, 4, 5, 6. Oh, yeah, that's interesting. Okay. Anyway, I think that's because I created a color which should have a 5-row by 3-column value, and then this set function is basically change the color for each of the line. We have in total 5 lines, so that's we need a 5 value from the color. We will have one question to practice in the lab assignments. So anyway, yeah, I will post the M file online and then for you to practice on Friday. I think that's pretty much of the demonstration what we need for MATLAB. But yeah, feel free to ask whatever questions if you have. So basically, that's a lecture and a demo today. Any questions?
On the quiz, will we have questions about mostly using these calls, or is it going to be more on the stuff we talked about earlier in the lecture about different types of visual or data visualization?
It would be mostly using the MATLAB building function, just call the function and then make the plot. So
okay.
Yeah, still it's focusing on solving the engineering question, but then now this particular lab session, you need to pay attention to the data visualization part, including so basically adding more like a figure legends, tweak the font size, make it more easily visible to other people. Okay, so which I think is not practiced in before. So now we need to pay a little bit more attention to make a more effective figure. Okay.
Got it. And this is for the lab or the quiz you need with
for the lab session. Mm-hmm.
Okay. Mm-hmm. And then for the quiz, is it based on like, will we have to have our MATLAB open and practice using calls?
Oh, for lecture 8, data visualization part, we don't have a quiz because
nice.
because next week the quiz time for lab session it will be the midterm exam.
Okay.
Yeah.
Got it. Thank you.
Good. All right. If no other questions, I think that's all for today. And I will upload the M file into lecture module. All right. Sounds good.
Thank you.
Mm-hmm.
Thank you.
Okay. Good.
Thank you.
All right. See you Friday.